Now, does every function have an inverse? Well, let's look at this function. One of our favorite functions we'll look at, f of x equals x squared. Remember how to find its inverse? Step one was about replacing f of x with y. Step two, switch the variables around. Step three, solve for y. Step four, if we could get to step four. However, we're stuck at step three here because we see that this is no longer a function. Y has two values for every x, and that produces what we know is something that's not a function. Now, are we able to tell that with what we have? What does that mean? What does that look like in this particular case of what's happening? So let's take an example here where we take some points, and I want to look at this graph of x squared. And there's a couple of points that we're familiar with. 0, 0. We have the point 1 and 1, the point negative 1 and 1, the point 2 and 4, and the point negative 2 and 4. And then if we were to graph those points, we see our graph of f of x. Now, I want to look at a couple of those points to get a sense of what is an inverse doing. So let's go ahead and look at the point negative 2 and 4. Let's look at negative 1 and 1. Let's look at 1 and 1. And let's look at the point 2 and 4. Now what an inverse does, it swaps the x and the y's around. So this first pair would become 4 and negative 2. And you can see that swap. The second pair becomes 1 and negative 1. The third one becomes 1 and 1. And the fourth one becomes 4 and 2. What we're able to notice there, that on the second line, we're also able to notice that this is not a function because both here, the ones, one produces a negative 1 and one produces a 1. Again, a function means that for every x value, there's a unique y value. This value of x produces two values of y. And likewise, this 4 that we notice here produces a negative 2, or it's at the place negative 2, and over here is at positive 2. So there's two indicators right now that what we have here is a function that doesn't have an inverse because its inverse is not a function. We're also able to notice what that means is that we have this idea about a horizontal line test. If we can draw some horizontal line across a function and it intersects that function into two places, then we know that that graph or that function does not have a function. It is not something that we're going to look at called one-to-one. So it fails a horizontal line test, and it is a function that, as we'll explore, we're also going to describe as not a one-to-one function.